There are two widely used methods to design filter. The first method will be using the image parameter, which I'm going to describe later on. Another method will be using the insertion loss. Basically, this method uses the Chebyshev table and also the Butterworth table to design the filter. This video, I will focus on the image parameter. As you can see from here, this is actually a low pass constant K filter session in the T session, and this is actually for the pi session. How you compute the L and C will be the formula as shown over here. So the key thing is the roll-off factor, okay, basically for this constant K low pass filter is limited to 6 dB per octane for each reactive element. Okay, so for example, okay, a filter consists of 3 inductor and 2 capacitor, which means that total they actually has 5 reactance element, and therefore we can conclude that the eventual roll-off for this low pass filter will be at 30 dB per octane. Let's come to an example to understand better. Okay, so this example tasks us to design a constant K low pass filter with the following spec. So from here you can see that the requirement is actually 5 elements as I explained over here. Okay, because with 5 elements, I will be able to achieve 30 dB per octane. So this is actually how I designed the T session. Okay, so imagine this is one T. Okay, another T will be over here. Okay, but over here you can count that there are actually 6 elements. 1, 2, 3, 4, 5, 6. But imagine these two will combine into one. So overall, I will only have 5 reactive elements. How to compute the L and C value will be using the equation that is actually listed over here. So from here, I have successfully designed a low pass filter meeting the spec of 30 dB per octane. If you need to know more, see the playlist under the description. Thank you so much.